The days of training a deep learning model on single machine with a single GPU are pretty much obsolete. Now the models and the data are too large to be handled by a single GPU. So we needed a technique to utilize multiple GPUs on a single machine or on multiple machines. For that, distributed data parallel was introduced. DDP is a parallel computing technique that allows us to training deep learning models across multiple machines, each equipped with one or more GPUs. It's a powerful tool that enables scaling of computational resources to handle larger models and dataset, thereby accelerating the training process. Let's see how it works. DDP operates by dividing a batch of input data into smaller mini batches. Each mini batch is then sent to a different GPU for processing. The model's parameters are replicated across each GPU and each takes a single step for that mini batch. When it completes the forward pass, each model will take a backward pass to compute gradients. Once we have gradient for all replicas, we will compute the final gradient. Since each model is trained on different mini batches, their gradients will be different as well. Here comes the all-reduce function from NVIDIA Collective Communication Library, or NCCL for short, which is a dedicated library to perform operations when it comes to parallel computing use cases. So all reduce will take gradient from each replica and compute an aggregated global gradient. This step is called gradient synchronization. Then it returns the gradient to all replicas. Hence, all replicas will have information about the state of every other replicas. And since now every model replica has the same gradients, the updated weight will be the same as well. This ensures that all GPUs maintain an identical copy of the model at all times. This process is repeated until the training is finished. Before the advent of DDP, data parallel was go-to method for parallelizing deep learning workloads. However, data parallel has significant limitation. It only utilizes GPUs located on a single machine. This restricts the amount of computational resource that can be leveraged, limiting the size of model and the dataset that can be handled. DDP addresses this issue by enabling the use of GPUs across multiple machines. This allows for the training of much larger models on much larger dataset, making it possible to tackle more complex problems. Here are 3 points that you can remember from this video. As mentioned earlier, DDP can utilize GPU across multiple machines, allowing for greater scalability. DDP reduces the computational overhead between GPUs by only synchronizing the gradients, which ultimately reduce the memory footprint. DDP allows each GPU to process a different mini batch size, enable greater flexibility in resource utilization. But what if a model's parameter get too large to fit on a single GPU, like GPT-3 or Llama 70 billion? To train these kind of models, we require sharding their parameters and storing them across multiple GPUs. That process is called FSDP, or fully sharded data parallel, and that's the story for the next video. Thanks for watching.